So the cloud is confusing. It's just simply put, the cloud is confusing. And one of the challenges is that the cloud is always off-site, right? It's always somewhere else. But yet you have all these computers, all these devices in your own office, maybe in your own home, in your own building, in your own manufacturing plant. Those devices could actually be working together and create your own cloud. I'm guessing this is what we're going to talk about, right?
You should come work with us. This is perfect.
I'm for hire.
We're Distributive. We're 5 years old. We're based in Kingston, Ontario, and we've built software that takes all of the computers, all the devices, all the phones, the fridges, the Tesla cars, you name it. If it has a processor, a CPU, or a GPU, we can put it into its own cloud, its own compute cluster, using a new, novel, web-based distributed compute platform. This takes all the compute and AI and data processing and advanced research computing and does it on these devices rather than in the cloud. So it's about 1/10 to 1/15 of the cost. Data stays in the building and allows anybody essentially to become practitioners of next generation AI solutions. Basically, we're operating in 3 main verticals: hospitals, manufacturers, and universities. All 3 have lots of idle devices and computers lying around, and all 3 have needs for advanced research computing or predictive analytics, machine vision, or what have you. So in a manufacturing use case, they use a lot of machine vision for quality assurance and safety programs and what have you. And we recently did a project with one of our customers, and we demonstrated how by moving their machine vision computations off of the commercial cloud and onto our compute platform using devices in their building, we reduced their cost by 16x. And this is real.
So I see, I don't mean to cut you off right there, but so this guy right here, it's actually working right now, right?
Yeah, so this is more or less of a stunt. You wouldn't use phones to do industrial level computations, but what we're proving is we can extract compute power from a headset like this to a phone like this to fridges and dishwashers and toasters and basically anything with a chip we can extract compute power from. We have a Microsoft Surface here. It's a tablet, laptop. It's running a screensaver. This screensaver is doing the same thing as this browser. It's able to go and fetch compute workloads like video footage and the neural network and all the different models it needs to apply, runs all the computations on the computer, sends all the results back. At the end of the day, when you're talking about the thousands of computers on a university campus, that's a lot of computing power.
Yes.
In fact, if you set up our screensaver on 1,000 computers in a school, that's worth $2 million worth of computing power per year that you would normally purchase from cloud. We unlock that on university campuses at a fraction of the cost. If people are getting interesting study at home vibes, it's because it's a very similar old concept, but built in today's age on complete web tech. Why web tech? Everything is web this, web that. Yeah. Everything's in the browser, Zoom, Google Docs, all this stuff is on the web platform. So we built a distributed compute platform like Apache Spark, but all on the web. So that means we can run on literally any IoT device. We are agnostic to the operating system, to the hardware itself, and distribute that compute anywhere. For enterprise deployments, we have a couple of flavors. We have screensavers that can get deployed in under 7 minutes to 2,000 computers using standard tools that all these places already use, like Microsoft Endpoint Configuration Manager or Active Directory or whatever their method is. We provide the software, it goes out, they get credentials, and then the screensavers, when active, i.e. whenever no one's using them, become an on-prem cloud to do all of that data processing and simulation that normally would be super expensive to do in the cloud. Now that being said, we're not anti-cloud. We also have a cloud worker that can augment on-prem compute networks by spawning these nodes on the cloud itself and then fusing both together.
I see.
So we like to think ourselves as water. We will adapt to any on-prem, off-prem, hybrid, multi-site architecture and get all those cycles from all those CPU and GPUs from any device, from anywhere, to do anything for anyone at a fraction of the cost.
So give me a case study.
We've been deploying screensavers in universities recently, and we've used it to do dark matter searches in galaxies.
Okay.
We've also deployed a bunch of these screensavers in hospitals to optimize surgical operating room block slates, and that's led to increasing in throughput by about 8% in surgical volume, just by doing better optimizations of the surgical scheduling itself. And all this needs sophisticated algorithms and sophisticated compute.
This is very interesting. How do we find out more about your company?
Come to distributive.network and check us out, and I'm happy to answer any questions anytime. Dan at distributive.network.
All right.
I'm happy to take you through it.
Thank you, Dan. This is Marlo Anderson, your guru of geek at CES 2023.